Hello. Um, this is a problem in our advanced calculus textbook. That's by Patrick Fitzpatrick. That's a second edition, and I'm going to be doing section 2.4 of problem number 7 of section 2.4. And the problem says a monotone sequence is bounded if it has a bounded subsequence. So I'll assume that I have a bounded sequence, a monotone sequence. Suppose an is monotone. Actually, I will assume an is increasing. So if it's not increasing, if it's a decreasing sequence, okay, so assume that an is increasing. If it's not increasing, then you can take the negative of an. If it's decreasing, you take the negative of n. It's increasing, so you can prove for the negative of n and use that one to show that n is bounded. Or you can replicate this theorem with a little adjustment. Okay, so let's assume n is increasing. What that means is if n is greater than m, then an is greater than or equal to am. That's what an increasing sequence is. Okay, and now let's let a and k be a bounded subsequence. Of the parent sequence an. Okay, now I'll be showing that an is bounded by the same bound as an k. Okay, so let's let a and k be bounded by m, which really means that minus m is less than a and k is less than m for each k. Okay, so let's let this be true for all k. Okay, now what I want to show is this sequence an is bounded by m. So for any randomly picked index m, I'll show am is less than this capital M. Okay, let's let m be just a random sequence in n. Okay, so recall that when we're building subsequences, the indices make a strictly increasing sequence of integers. So when m is in n, we can show that n subscript m, we've done this in class, is greater than or equal to m. Okay, and therefore a with subscript a and m is greater than or equal to a with subscript m. Okay, it's supposed to be little m, so that am, which is less or equal to a and m, is less than the capital M that I had for the bound of a, that's the subsequence. Well, since an is an increasing sequence, we get that a1 is less than or equal to am is less or equal to m for each m. That is, the sequence an is a bounded sequence. So, okay, so if an is increasing and has a bounded subsequence, then it's bounded. If it was decreasing, we can take the negative of an, which will be an increasing sequence, and since it has a bounded subsequence, then it should be bounded, and that would be a nice two-line proof using what is proven here. All right, well, thank you so much. I'm going to do another one problem in a few minutes. Take care.